The topic for today is effects of concentration, pressure, and nature of reactants. Concentration, pressure, and nature of reactants all have effects on the rate of chemical reaction. Effects of concentration, pressure, and nature of reactants. An increase in the concentration of reactants will increase the rate of reaction. This is because when the concentration is increased, the reactant particles will be crowded the more in the same space, resulting in a more frequent collision. The higher the frequency of collision, the higher the rate of reaction. The lower the concentration, the higher the amount of space between particles, the lower the frequency of collision, the lower the rate of reaction. In the reaction between magnesium and hydrochloric acid, according to this equation, 0.5 moles of HCl aqueous will react faster than 0.1 moles of HCl aqueous in excess magnesium metal. Pressure. Pressure affects the concentration of gaseous reactants. The concentration of solid and liquid reactants is not affected by changes in pressure. Pressure will affect the reaction below. Hydrogen gas plus chlorine gas to give hydrogen chloride gas. Nature of reactants. The rate of chemical reaction is determined by the chemical nature of the reactants because different substances have different energy contents. Sodium will react with dilute hydrochloric acid with an explosion and rapid evolution of hydrogen gas. When iron is placed in the same concentration of hydrochloric acid, there will be slow evolution of hydrogen gas. When a piece of gold is used, there will be no evidence of reaction. Examples. Number 1. The rate of a reaction usually decreases with a decrease in the concentration of reactants because A. Kinetic energy decreases. B. Temperature increases. C. Speed increases. D. Reactants collision decreases. The correct answer is option D because decrease in concentration of reactants will result into a decrease of the collision of the reactant particles, which will also lead to a decrease in the rate of reaction. A cannot be the answer because kinetic energy does not have effect on concentration. B cannot be the answer because if the temperature increases, the rate of reaction will increase. C cannot be the answer because when speed increases, it means increase in collision, which will lead to increase in the rate of reaction. Number 2. Zinc plus hydrochloric acid to give zinc chloride plus hydrogen. Which of the following concentrations will produce the highest rate of reaction? A. 2 moles per dm cube of HCl. B. 0.2 moles per dm cube of HCl. C. 0.1 moles per dm cube of HCl. D. 1.0 moles per dm cube of HCl. The correct answer is option A because 2 moles per dm cube of HCl has the highest concentration of hydrochloric acid. Option B cannot be the answer because 0.2 moles per dm cube of HCl is lower than 2 moles per dm cube of HCl. Option C cannot be the right answer because 0.1 mole per dm cube of HCl is lower than 2 moles per dm cube of HCl. Option D cannot be the answer because 1.0 moles per dm cube of HCl is lower or smaller than 2 moles per dm cube of HCl. Number 3. The highest rate of production of carbon 4 oxide can be achieved using a 0.05 moles per dm cube HCl and 5 gram powdered calcium trioxocarbonate 4. B. 0.05 moles per dm cube of HCl and 5 gram lump calcium trioxocarbonate 4. C. 0.1 moles per dm cube HCl and 5 gram powdered calcium trioxocarbonate 4. D. 0.025 moles per dm cube HCl and 5 gram powdered calcium trioxocarbonate 4. The correct answer is option C, 0.1 moles per dm cube HCl and 5 gram powdered calcium trioxocarbonate 4, because 0.1 moles per dm cube is the highest concentration of HCl out of the 4, and also 5 gram powdered calcium trioxocarbonate 4 has a large surface area since it is powdered. Option A cannot be the answer because 0.05 moles per dm cube HCl is lower in concentration when compared to 0.1 moles per dm cube. Option B cannot be the answer for the same reason. 0.05 moles per dm cube is smaller than 0.01 moles per dm cube. Option D cannot be the answer because 0.025 moles per dm cube is lower than 0.1 moles per dm cube in concentration.